The Digital Twin certificate program in AI and analytics is really geared toward professionals. We're interested in helping them to equip themselves with not just the knowledge, but also the skills integrated together to be able to help sort of promote that paradigm shift within their respective industries to support digital twin adoption. This is really one of the first sort of integrated digital twin programs that exists at the graduate level, particularly for folks who are in industry. And it's particularly unique in that it's really taking a head-on and direct approach to rigorously defining what a digital twin is in the first place. In our mind and in our program, a digital twin is really a virtual representation of a physical model that's able to mirror things like its context, its behavior, the information it contains, so that we can use that to more efficiently make good decisions about our physical asset. Say civil engineers, of course, we're the engineers that deal with the built environment most, right? Every day, whether you're in industry or whether you're in academia or a student, you're dealing with the built-in physical environment. And especially in civil and environmental engineering, these types of built environment components are not things that we can go out and make changes to on an everyday basis. We need these virtual representations that we can look at various types of what-if scenarios to see what's going to improve the performance, reduce things like downtime, inefficiency within our built environment before we actually have to go out and make those costly changes. I think a lot of people, particularly in industry, are a little overwhelmed by the variety of different definitions of a digital twin that are floating out around there. And we're really aiming to demystify that within this program. There's two main parts of our program. Teaching students about how to gain the knowledge about a digital twin, give them the ability to feel confident in understanding how the different pieces and components come together, particularly within different contexts of their industry, followed by a second course that's much more focused on the analytics piece of it. One thing to emphasize is this is an actual course that we are actually implementing in our real curriculum on CMU's campus in person, right? So this is not a course that's been watered down for an online format or anything like that. And we've got into this online format really deliberately. And a really good example of this is a course project that we actually have that threads through both of our two courses. So whether you take one or both of these courses, it is a project that you'll see. And what we've basically done is we've developed a 20-foot robotic locomotive testbed, basically. And what we've enabled is remote control over this. So no matter where in the world you are taking this online certificate course, when you do your project and you have to collect data, you'll be able to go into our web interface, actually operate the train, change its different parameters. In this case, you might change its speed or the configuration of the bridge or the configuration of the locomotive itself. Collect data that basically goes into a zip file that's sent back to you, and there's a camera looking down on it so that you can see it moving in real time. And you'll be using in your course project this data to make decisions about how to manage the bridge, detect damage, and things like this. This is critical because at the end of the day, we'll be talking about in our course a lot how a digital twin, right? It's the virtual representation that mirrors the built environment. If you're going to be doing a course project that's truly working with digital twins, you need information that's being generated from the built environment, that's changing configurations, that's evolving continuously, just like that definition of a digital twin, taking that information to make better decisions. So the course project is supposed to mirror a digital twin process and definition, and even if you're not physically here, still be able to benefit from that. What really excites me the most is the program's not geared towards just making good engineers who can make decisions, but ones who can make really good decisions. So in addition to having that analytical rigor of our program, we're integrating in a lot of really interesting components, things like how to make a good business case for a digital twin. And these are done really intentionally so that our graduates can go out into the real world and not just implement this, but be sort of catalysts and leaders of change within their fields. Being able to interface with people who are not experts in this and try to help sort of demystify themselves what this means, why they should adopt this, how they should adopt it, and what types of people should be brought on board to make this happen.